Welcome to this session. Today we are going to discuss a simply supported beam with point loads and uniformly distributed load. For this we are going to find the support reactions, shear force values on each and every point as well as the bending moment values. Finally we have to draw a shear force diagram and a bending moment diagram. In the area classes we have discussed the same thing, simply supported beam with the point loads. Here uniformly distributed is included. So how we are going to find out the shear force values and bending moment values as well as the shear force diagram and bending moment diagrams. Let's start. So this is a simply supported beam A and B which are supported by extreme ends, and we have 2 point loads at C and D. So the distance 3 meter and from C to D is 2 meter. And we have a uniformly distributed load UDL of 20 kN per meter. Okay. Now, how to find out the support reaction first? So we have support reactions at point A. Let's take what is RA as well as RB. So this is the first thing we are going to support. First, let's project here. To draw the shear force and bending moment diagrams, just extend. So we have points A, C, D, E, B. Okay. As we have discussed earlier, we have to use the statically equivalent equation sigma V that is equal to 0. The sign convention upward force is positive, and we have the force RA minus 50, minus 60, and the UDL of 20 kN per meter, and it is a downward force and it is a intensity of force, that is per unit meter it is given. So we have to convert it to the point load. Already discussed in the earlier videos. So 20 into 6 will give you the point load. Since it's a down load, so 20 into 6 is the point load, and we have another support reaction RB which is upward. So that is equal to 0. Okay. So we have RA plus RB. Just shift all the values to the right hand side. So 50 plus 60 plus this is 120. So totally 110 plus. So we have 230 kN RA plus RB. Let's have one equation. So find either RA or RB, we can find another one. Let's take this as equation 1. Okay. Next, we can go for the another statically equivalent equation by means of having the bending moment sigma m at any point. I am taking the point where the support is there. So at point A I am taking, that is equal to 0. So what is the sign convention? So I am taking clockwise as positive, anti-clockwise as negative. Now let's take the moment, okay, at point A. So now all forces should reach the point A in the clockwise manner or anti-clockwise manner with the sign convention we have to consider. So 50 into 3, 60 into 5, and UDL. First consider whether it is going to approach the point clockwise or anti-clockwise. Since it is the downward load, it approaches the point A clockwise, so it is positive. And what is the load? Load is 20 into 6. That is the load. And what is the perpendicular distance? That is the very important thing we are going to consider why UDL is appearing. Okay. Now, where this 20 into 6, that is called 120 Newton, it exactly acts at the center point for the UDL, already discussed in the earlier video. Okay. And what is the thing? Here 3 meter and this side 3 meter. So from this point, okay, this is acting only here. Okay. So 3 plus 1 plus 2 plus 3, totally 9. 9 meter is the perpendicular distance to A, and the reaction B. It is upward force, so it travels to A in the anti-clockwise, which is taken as negative value. So RB into 12. Okay, RB into 12. So all the forces are considered. So finally that is equal to 0. So what is the value? So 150 plus 300 plus this is 120 into 9. So that is 1080. That is equal to 12 RB. So what is the total? This is 450. 450 plus 180. 450 plus 180. Just add. So we will get so 1532. Okay. For 12 RB equal to 1530 kilonewton. Okay. And what is the RB value alone? From this, RB equal to, so 1530 divided by 12. So 1, that is 90. 90 means 7. That is 127.5 kilometer. So 127.5 kilonewton is the support reaction value. Okay. Now RA plus RB equal to 230. So what about the another value RA? Just subtract from 230. So RA equal to, so now just I erase it here. So RA that is equal to 230 minus 127.5. That value equal to 172.5. Okay. 230, that is 127.5. So it is 5. This is 6. 2, then it is 0, 1. So that value equal to that is 102.5. Okay. That is 102.5 kilonewton. RA equal to 102.5 kilonewton. That is the value of RA. Now let's move on to finding the shear force values. Okay, how to find shear force values? Shear force, I just write as F, and at a particular point F, at a B point, on each and every point I am going to find. So I know the sign convention is right up is positive. Remaining everything is reversible, and it is negative. Okay. Next, first I am considering the reference points. So F at the B point, consider the right side. So right up value. So that is equal to positive. That value equal to RB. Just mark this one. Okay. RA. So RB equal to 127.5 kilonewton and RA equal to 102.5 kilonewton. Okay. Here simply FB equal to 127.5 kilonewton. What about F at B point? So from this point, consider the right side, you have RB value and the UDL. So this is upward, this is downward. So take downward as negative. So 127.5 minus this value. The value is, we are considering only the force. So that is 120. 20 into 6. That is 120. So totally we have 7.5 kilonewton at the shear force at point E. And let's move on to the D point. F at D. Okay. So put together, we have already considered RB and this value. And the extra thing is 60 kilonewtons come into picture. We just consider from this point 7.5 already considered RB and UDL. And remaining here 60. And it is the downward force. Right up is positive, down is negative. So this is minus 60. So that is equal to minus 52.5 kilonewton. Okay, this is FD. Okay, so next move on to this another point. Now let's move on to this point F at C point. So up to this we have found out that is minus 52.5, and at point C 50 kilonewton is included, and the right side you just consider this downward. So use another thing. So negative. So it is minus 102.5 kilonewton. Okay, this is FC. Next FA. So this is the reference point. So consider right side, already everything has been considered to see. In between there is no load. So what the shear force value is there for at FC, that the same value will come for point A. Otherwise, we consider this point, consider left side, left up is negative, the value is 102.5. So it is minus 102.5. The same thing. Now we have found all the values for shear force of each and every point. Okay. Now we have already found all the values of shear force at each and every point. Okay. So now let's draw the shear force diagram. It will be a zero shear force line. Now just placing the values of FB at B point is 127.5. So 127.5 kilonewton. At point B it is 7.5, just near to it is 7.5 kilonewton. And at point B, at point B it is negative minus 52.5. So it goes okay, 52.5 kilonewton. And at point C it is the same value. Okay. At point D it is, at point C it is minus 102.5. Okay. So it goes, you know that value. So 102.5 kilonewton. At point A, the same value, it is 102.5 kilonewton. Now let's draw the diagram. For shear force, if it is UDL, how to draw? It is nothing but you directly join the 2 points from B to E. So from B to E, you just directly join it. Next, from E to D, there is no UDL, so draw a horizontal line where the point is acting. For point here, you just a vertical line. In between B to C is also same thing. Draw a horizontal line. And the point of load, draw a vertical line. And C to A, there is no UDL, so 102.5 is a horizontal line. Okay. So this is negative shear force. This is the positive shear force. Close the value to 0. Okay. This is the shear force diagram. Okay. Now let's go on to finding the bending moment values at each and every point. So bending moment, let's take a BM at each and every point and then bending moment as M at the B value. For B value, this force resistance, so definitely it is equal to 0 value. As well as the sign convention, the upward force will produce the positive bending moment. Okay. So let's go for the point E. Okay, M at the E point. And here I consider right side you have RB and UDL. So RB means direct load. So force into perpendicular distance and approaches the point E as the anticlockwise. Okay, and it is upward force. Upward force produces the positive bending moment. So directly we have to take positive. So 127.5 into 6 meter. And you have another load as UDL. So the load as UDL means, and it is a downward force. So to be taken as negative bending moment. So it is 20 into 6, 120. Then what is the distance from that point to E? So half of the distance. It is 3 meter. It is 3 meter. Next, consider the point D. Okay, and it is also downward force. Otherwise, consider left side also. Okay, you consider the left side also. If you consider left side, you have only R, A and 50 kN alone. Okay, now consider this the left side. So there is 102.5 M at C D point. From the reference point, consider the left side only 2 loads. So it is easy to convert. So that is 102.5. It's a positive bending moment because it's a upward load into the point D. So 3 plus 2 is 5 meter. Next you have a 50 kN. The downward load produces the positive negative bending moment, that is 60 into what is the distance to D point? C to D is 2 meter. Okay, this is MD, and we have to find the load also, values of MD. Here it is 5.5, 25, 5 times 12 and 51. Okay, 512.5 minus 120, and totally it is 400 not 7.5 kilonewton meter. 407.5 kilonewton meter is M at the D point. And here also M at E we have to find. It is 6 into 127.5. So this is 0. 6 into 530, 42. 45, 6 12 are 12, so 4 16, 765 minus 120 by 3 is 360. So what is the remaining value? It is simply it is 305 kilonewton meter. So this is the M at E point. 305, M at D equal to 407.5 km. Next, we have to find the bending moment at the point C. MC, same, consider the left side. Otherwise, if you go for the right side, you have number of loads. It takes more time. Okay, so if you consider the left side, only one load, RA upward force, and the distance is 3 meter. There is nothing but the positive bending moment 102.5 into 3. That's all. That is equal to 307.5. kilonewton meter. This is m at the point. So these are the values we are going to consider. Now we are going to draw the bending diagram by using these values. And the ME also we have to find. Consider let's say we don't have any distance is equal to 0. Okay, just erase the Shear Force diagram. This is a 0 bending moment line. So at the point B it is 0, at A it also is 0. Okay. At M at E that is equal to 305, the positive value. So M at E is 305 kilonewton meter. Next M at D point is 407.5. 407. This is 305 kilonewton meter. M at D it is 407.5 kilonewton meter, and M at C it is 307.5. Okay, so just here 307.5 kilonewton meter, and M at A that is equal to 0. Now how to draw the diagram, that is the important thing. Whenever uniformly distributed is included in the beam, the bending moment diagram, the nature of curve will be a parabolic. Since it's a positive, okay, just E to B, that area alone, it's a parabolic curve. Goes on increasing. Then here the other regions there is no point, sorry, there is no UDL, uniformly distributed. Only point nodes are available. So just the bending moment diagram here, you just directly join the points. Okay, from E to D. At the D point it is 407.5. Just draw the linear line. Here draw the line. Okay. Here also. These are the linear straight lines or inclined lines. Okay. So everything is positive bending moment diagram. There is no negative values at all in the bending moment. So this is the methodology to draw the bending moment diagram for the given problem. Okay, so this is the steps we have to include, and whenever the bending moment diagram is bending moment values are calculated, it includes the distance also. So the uniformly distributed load will be calculated more here. Okay, so that's all in this task. We will solve another problem with UDL and the point nodes with intersecting in between. If it is there, how to solve the problem. Okay, thank you.